Welcome everyone. I'm sitting here today with Hanna Ritzén, the Managing Director of R&D at Mercodia. Hanna, you've been working with Mercodia for 16 years now, and you've become an expert in measurement quality. Could you help us better understand this term, please?
Thank you, and I'll do my best since measurement quality is a broad and general term. Narrowing it down to immunoassays, where we want to measure a sample, serum or plasma, to detect a concentration, I would pinpoint it down to two crucial words: accuracy and reliability.
Okay, so could you explain this further, please?
With accuracy, we want to get as close as possible to the true value. We want to have a specific measurement with no interactions from the sample matrix or cross-reactivities for other substances. Reliability, we want to be able to repeat our analysis within the same lab, repeatability, or between labs, reproducibilities, and even between kit lots. To maintain good measurement quality, we use lifecycle management.
So what is lifecycle management?
Lifecycle management is also a general term. It's discussed in various white papers, but are lacking in regulatory guidances. Product lifecycle management starts with the idea to design and development, manufacturing, and the disposal of a product. It also integrates data, people, and businesses, process, and systems.
So how could lifecycle management look like in terms of ligand binding assays?
ELISA assays are used in a huge range of different studies: early exploratory, non-regulated bioanalysis, screening for a biomarker, and regulated bioanalysis and clinical diagnostics. Let's say you use your in-house developed assay for one specific study, or you use a fully validated method for regulated bioanalysis or clinical diagnostics. The use of lifecycle management might look different.
So it seems like lifecycle management differ from study to study depending on the purpose of the project.
Exactly. At Mercodia, where we believe that accuracy matters, we have chosen to implement lifecycle management for our assays with the design and development, production, quality control, stability studies, and corrective and preventive action that closes the circle of lifecycle management.
Thank you, Hanna.
Thank you.
Next time, we'll dig deeper into the details of lifecycle management. Welcome back, everybody. Hanna, could you please give us a more thorough session about life cycle management?
I sure can. It's a quite complex process. However, to improve efficiency in drug development, to draw reliable conclusions, and to trust our data and methods, we think it's needed. As we talked about last time, life cycle management might look different depending on the intended use of the data. But in general perspective, for ligand binding assays, we have 5 categories: design and development, production, quality control, stability studies, and corrective and preventive actions.
Great. So this time, could you take us through the design and development step?
Yes, design and development might not appear as rocket science, but it's crucial to ensure that a method gives us reliable and reproducible results over time with minimal lot-to-lot variability.
So how do we achieve that?
I would say that we need to start with having reliable reagents. We have categorized our raw material into 3 categories. The first one, antibodies and antigen. Then we have proteins and lipids, microtiter plates. And the last one would be list items like salts and enzyme inhibitors. A company like Mercodia qualified according to ISO 13485 need to ensure the vendors have a quality system in place. By doing this work early on in the process, we do not only establish the method and acceptance criteria for raw material, but we can also help us to choose the most suited antibodies to be able to tailor assay performance.
I read a publication where I understood that calibration is also of high importance. What's your take on this?
I totally agree, and in contrast to PK assays where we have a well-defined calibrated material since it's our drug, for biomarker assays we need to study stability, reactivity, purity and concentration, and traceable to an international reference preparation if available.
Okay, now we have discussed the critical raw materials. What more do we need to keep in mind to design a reliable assay?
That is, of course, a lot of things, but I would say that we need to optimize coding and conjugation procedure, assay protocol, buffers, etc. We need to ensure not only specificity and sensitivity, we also want to design a robust assay that's easily transferred to production.
Okay, thank you, Hanna.
Thank you.
Next time, we will continue with the next two steps in the lifecycle management, the production and quality control.